All right, well, now we're going to look at parallelograms on the coordinate plane. And what we're going to do is we're going to review what we're being asked to do. And then I'm going to go over to GeoGebra and actually graph this thing. And then we're going to come back to this, and we're actually going to find what we're asked to do, which is determine the coordinates of the intersection of the diagonals in this parallelogram. But then we're going to come back to it and show how we can also find that using the midpoint formula. So let's see what we're asked to do. We're asked to determine the coordinates of the intersection of the diagonals of RSTU with vertices of -8, -2. R is equal to that. S, vertices S is -6, 7. Vertices T is the coordinate 6 and 7. And U, vertices U, is the coordinate 4, -2. So let's jump over here to GeoGebra. We'll graph it. Obviously, you can do it on graph paper or some other method. And then we'll come back and algebraically determine how we can find the intersection of the diagonals. Okay, so here we are. We're in GeoGebra, and let's graph this. So we've got what the coordinates are of the 4 vertices for parallelogram RSTU. And so we want to define a point. And so R equals -8, -2, and enter, and that puts R there. And by the way, I'm going to move that R because I know it's going to be in the way. So I can just put my cursor over it, and I'm going to move it over here. All right, let's see. Coordinate, our vertices S equals -6, 7. And there's S. And vertices T equals 6, 7. And vertices U equals 4, -2. I think I'm going to move that label there a little bit too. Okay. All right, now I'm going to go to my segment tool, and I'm going to connect these points. So I'm going to connect R to S and S to T. And T to U and U to R. Okay, so that looks like a parallelogram. And now we're going to connect our diagonals. So my diagonals are these opposite vertices. So I'm going to continue with my segment tool, and we're going to connect R to T. And then we're going to connect S to U. And you can see that we do have a point of intersection right here. But let's define where that is. And I can do that by going to go back to my point and say that I want to find the intersection. And I'm going to put it right in here. And boom, there's my intersection. And if I look right down here to the left where you see my cursor flashing back and forth, that point of intersection is at the point where x is equal to -1 and y is equal to 2.5. And if I look at that and verify that, there's x -1, and that looks to be about 2.5. So that looks about right. All right, so our opposite vertices were R and T and S and U. And we're going to use that to continue with this to algebraically find that coordinate. All right, so since I know now that R and T were opposite vertices, and S and U were opposite vertices, I can use that to find the intersection of the two diagonals. So if I'm going to use R and T first, I'm going to take -8, which is that value, X value, plus 6, which is that value for T over 2. That's going to be my X coordinate. And my Y coordinate is going to be -2 plus 7 over 2 using those coordinates. All right, let's see. -6 plus 6 is going to be -2 over 2. -2 plus 7 is going to be 5, give me 5 over 2. And then when I simplify that, I get -1, comma, 2.5, which is exactly what we found on GeoGebra. Now, because these things bisect, I really only need to find one of those. But let's just verify that those are going to intersect at the same point by finding the midpoint of S and U. So we're going to go about that the same way. I've got -6 plus 4 over 2, using that X coordinate, comma, and then use my Y coordinate, 7 minus 2 plus -2 minus 2 over 2. And let's see, -6 plus 4 gives me -2 over 2. 7 minus 2 gives me 5 over 2. And Shazam, I get the same coordinate, -1 and 2.5. Okay, then we find it by graphing it, determining the intersection of the diagonals, but also once we determine exactly where our opposite vertices are, we can do it algebraically and come up with the same answer. Because, you know why? Because that's the correct answer.